kind of a strange file created on your computer, or sometimes you notice that a file get corrupted or deleted and all kinds of things. So these are the sign of malware infection and contamination. So the task for the malware investigator is to catch these signs as soon as possible. And as you will see, this is not always easy. And once you identify the infection or the intrusion of a malware, the following tasks are the following. First of all, you need to kind of investigate through which software or through which vulnerability, right, did this malware infect your system. So there must be a door, there must be a kind of a leak in your system that kind of attract or that kind of led to the successful intrusion into your system. So the first task is to identify the break-in point. The break-in point is usually a vulnerable software, a software that communicates with the outside world. For example, on the server side, a vulnerable software can be a web server or a DNS server or other server software. And on the client side, this vulnerable software can be your web browser, your email reader, or your instant messenger software, right? And then once you identify the breaking point, that kind of only completes the first step of the malware investigation. The second step is to enumerate or to identify all the damages that the malware has done to your system during its residence. So this is also important because you want to understand what kind of harm the malware does to your system, and in some cases you may want to recover from the damages done by the malware. So these are the two things: identifying the breaking point. Number two, identifying all the contaminations. Okay, so like in the defense against the malware, right, or in accomplishing the two tasks that I just mentioned, the researchers and practitioners have developed a number of powerful tools based on logs, right? So I want to show you briefly how does some of the current log-based malware intrusion investigation tool respond to a malware incident. So let's take the internet worm, for example. Let's say this is a worm that targets the vulnerability of a specific version of a web server, right? So once compromising your web server, right, this worm, right, in this case, so that's the incidence of the malware, will create, for example, additional processes, right? For example, the most typical one being, like opening a shell. So this shell process can further spawn multiple processes. Some of the processes, like this netcat, will actually scan or look into your files. So this kind of can potentially lead to the unauthorized disclosure of file content of your machine. And also, it can modify or it can corrupt local files, right? I mean, by this shell process. And it can further spawn processes that will further download additional malware into your system. For example, this is how the malicious attacker install like backdoor or rootkit in your system, right? So these are the bad things done by this malware after entering your system. So it enters through the breaking point of the vulnerable HTTPD daemon, right? That's its breaking point. And after breaking into your system, it performs a number of things, right, in the steps. So the current log-based approach, the current log-based tool for malware defense, they actually record the steps or the system calls made by the malware or by the relevant processes, and they are able to reconstruct the bad things done by the malware once once the malware existence or once the presence of the malware is detected. So this relies on a thing we call the detection point. So here, if you see the alert, right? For example, I noticed that a rootkit has been installed in my machine. So that is what we call an external detection point. So from this detection point, we want to answer the question: what is the original breaking point, right? What's the vulnerability? What's the specific vulnerability of my system that ultimately led to the installation of this specific rootkit? So that's the first question. The second question we want to answer once you have that external detection point is the identification of all the damages, right? Because in addition to the rootkit installation, this malware does other bad things, including, for example, reading your files, creating additional processes, or downloading additional malicious software, things like that. So you are supposed to identify all these actions. right? So these are the things that the malware investigation is supposed to uncover. So let's take a look at how these two steps are done by the current log-based investigation tool. So it starts from the collection of log. So by logging the system calls made by the malware or made by the malicious processes created by the malware, so you can actually see a whole bunch of actions, in the form of system calls, right, during the residence of this malware. For example, including the creation of new processes, the reading of files, the downloading of, the opening of a new socket, downloading additional malicious software, things like that. So every system call is logged, right? And these log entries are stored in a log file for, for future forensic investigation. So everything I just talked about, namely the collection of log, happens during the runtime of the system. Right? And then at some point, so this some point could be like days or weeks or even months later, after the initial intrusion of the malware. So at that point, maybe as a user, I realized that I found this, kind of a weird file or this, malicious process running in my system. So that is considered the external detection point, because that one, that sign is noticed by me, the user, right? And once I notice this, anomaly, I will report this to my system administrator, right? And then the administrator will kind of retrieve. So this, now everything, I talk about next happens offline. So once this incident or this detection point is reported to the system administrator, the system administrator will use the log entries, right, that have been collected to perform the investigation. So the first step of the investigation is to retrieve all the previous log entries, right, from, in the past week, month, or even year, right? And then it would start a reconstruction process. So this reconstruction process starts from the detection point, right? It will start from the corresponding log entry that logs the action of installing this rootkit. And we will go all the way back to the original breaking point of this malware incident. So once you identify, for example, that specific software that communicates with the outside world, namely, in this case, the HTTP daemon, we can tell that the initial breaking point of this malware incident is a vulnerable web server, right? So by doing that, we kind of backtracking the actions performed by this malware based on the log entries that have been collected in the past. So you now so notice that this backtracking process uses the entire log file as its input, right? It just grabbed the relevant log entries and put them in the right place and reconstruct the story, right? So now we complete the first step of a malware investigation procedure, and there is a second step. Namely, I need to identify all the other damages, because as you realize, these are not the only damages done by the malware, because it does something more, right? And then with this breaking point identified, we are able to again use the log entries collected, and we will kind of pull out the relevant log entries and construct, the entire graph. And this graph kind of identifies or reveals all the steps, all the bad things done by the malware. So that kind of completes the process of malware investigation using the log that has been collected. Right? So this is the state of the art. This is the typical workflow of doing malware investigation or forensics. So we identify a number of problems with these with these tools. So the first problem is that, as you realize, in order to go from your detection point all the way to the breaking point, to the initial breaking point, you have to use the entire log file, right, as input. You need to pull out, you need to scan all the log entries, and you need to construct the graph. And you can imagine that the construction of the graph is pretty computation intensive, because it involves the scanning and the examination of all the log entry in the log file. So basically, it needs to analyze the entire log, right, in order to identify the breaking point. So once you identify the breaking point, you also need the entire log to identify all the contaminations. So basically,